All right, let's get started. Welcome to our webinar on Arango ML Pipeline Cloud. Basically, how can we move from data to managed metadata if we're talking about machine learning? And furthermore, if you want the TLDR of what you're going to see, we will talk about different ways in which data is important for your machine learning pipeline. I mean, most of us, we think about training data and validation data, but we'll also talk about the machine learning metadata. And we'll talk a little bit about what are easy ways to actually store, access, and then also leverage that kind of metadata. And for that, we'll announce and showcase ArangoML Pipeline Cloud, a managed solution for machine learning metadata we recently announced. And also, ArangoML Pipeline Cloud is an open source project. So in theory, you can also just push that yourself or deploy that yourself. That's Jörg. I'm the head of engineering at machine learning here at ArangoDB. Prior to that, I worked on a lot of large-scale infrastructure projects over at Suki, Mesosphere, or now D2IQ. And so I built a bunch of different machine learning platforms in both finance, healthcare, and those are kind of my two passions, databases and machine learning infrastructure. And this is why I'm super excited about the Arango ML Pipeline project, because there I can actually combine both those passions. With me today is Chris. He's our developer relations engineer. And so probably if you have been in contact with ArangoDB, you probably have seen at least one of his great videos. Otherwise, if you haven't, you should definitely check that out, or the Udemy course also on getting started with ArangoDB. And he will also just present us today a demo about Arango ML Pipeline Cloud. So super excited about that. Thanks for joining, Chris. Why do we care about metadata? So typically, if we think about our data scientists, TensorFlow, it's super exciting. I don't know how many of you have just tried one of those tutorials. You don't even have to install anything nowadays, as there's Colab or Binder Hub, where you can just run notebooks off the internet. And so no need even to install anything on your laptop. Makes it very easy to start. But after we get started, we feel like we're the superhero. We've gone through all the tutorials. We have large amounts of data available. There are those massive data centers over at Google, Amazon, or Microsoft, which actually allow us, together with really cool advances, especially in like deep neural networks, to be like a real superhero and solve really cool problems in just a notebook by just typing some Python code. So it's really easy to get started in machine learning nowadays. But on the other hand, it's still kind of hard to really deploy that into production, because what we believe data scientists are doing when they're writing that models is we get like some magic data set, we write our machine learning code from our Jupyter notebook, we train a model, that model obviously is perfect, we hand it over to the operations people, and everyone is happy because we now just delivered a really cool result, and we can start over with the next problem. Unfortunately, reality is slightly more challenging than that. If we look at what's actually happening in machine learning, or what data scientists are doing all day long, this only small black box here in the middle is the machine learning code. And all of the stuff around is from like data collection over verification, feature extraction, QA, serving infrastructure, monitoring. So the actual challenges are not necessarily the machine learning code, but the actual challenges is how can I get that entire thing operational and generate business value out of it. And so what ends up typically, we end up building a machine learning pipeline with different stages, and there might also be different people involved. Like nowadays, it's very common that the data scientist, he can actually focus on like the first half of this pipeline, and then later on the model management or model serving. This is typically taken over by more DevOps people, or the new term for those people often is data ops. And so this machine learning pipeline goes from like the data storage over feature engineering or data pre-processing, where I try to first clean up a data set and then extract meaningful features out of it. And then comes the model training, which we typically associate with machine learning, with all those cool frameworks, TensorFlow, PyTorch, Spark, MXNet, or what else is all out there. After we are done there, we end up with a bunch of models. This is a common misconception. We get like one model. Typically, we have a number of different variants. And then over time, when we also get new training data or training data is shifting because the distribution is, of, for example, our website request is changing over time, we actually end up with a large number of models which we have to track, store, and manage overall. And then we also have to serve the models, so actually hit them with live traffic and utilize them to make decisions or predictions. So one example for such pipelines is, for example, TensorFlow extended. And only here, this small part in the middle, this is like the Keras model, which we typically associate with TensorFlow. But TensorFlow actually has a lot of different tooling around helping us to cover this entire machine learning pipeline, from data validation over transformations, over validation of our outcomes, and then also over model serving in the end. And now you might actually wonder, both Chris and I, we work at ArangoDB, which is a database company. Why do we care about TensorFlow extended or such machine learning pipelines? So maybe in short, ArangoDB, it's a native multi-model database. What does that mean? That actually means it can store graphs, documents, and key values. So all those typical NoSQL data models in one engine. Often if you start, for example, using a simple graph database or a document database, soon you figure out, oh, actually one data type isn't enough. And that was kind of the main motivation behind ArangoDB, to have one data store which actually allows you to combine all of that in one engine, reducing the operational effort. And also from a performance point, as everything is in one engine, you don't have to merge it somewhere outside in your application code. It's distributed, so for example, also you can have graphs spanning multiple nodes. There is a SQL-like query language, and we also support asset transactions as long as you're staying within like the bounds of a single node. So as mentioned, like, why do we actually care about that? Databases are a very big factor if we're talking about those machine learning pipelines. So let's take a look where they appear here. So I think the most natural way, which every one of us is immediately thinking about, is kind of the data side, where we store data, where we persist data. So there a database feels very natural. The second part where databases are often used is in feature engineering. When I actually need to extract value from my initial data set, databases can be very helpful here. So for this feature engineering, where I get some raw data, and that might be a JSON, that might be a graph, and then I have to generate some input which TensorFlow can then understand. So for example, TensorFlow, the normal input format, the TF records, it's like columnar based, so more like a relational based setup. And what do I do if I, for example, have a graph? So here, like the IMDb movie graph, how can I actually feed that into TensorFlow? So there I often need some pre-processing, and this is where we have a number of users who actually do that with ArangoDB. Furthermore, also we support Arango Search, which is like a full text retrieval engine. And so I can also do some basic natural language processing already in the database, and then generate my features, which can then be used by TensorFlow, MXNet, or your favorite machine learning framework. Maybe just kind of like an outtake, like one really exciting development also from research in that area are, in my opinion, graph neural networks. And so, for example, we right now have released a first version of Node2Vec, which is basically that combination of, if I have a graph somewhere, how can I feed that into a neural network, and then the neural network can actually understand that. So there are some really cool developments, because that will allow us to combine graphs, which is a natural way for us humans to formulate and think about certain problems with those neural networks. So stay tuned there, and also check out, for example, Node2Vec on the Arango ML side. But kind of the last part and the part we want to talk about is actually more about how can a database help us to manage this entire pipeline. So one of the challenges we came up with in the past when implementing such pipelines was, for example, we were dealing with patient records. There's a patient record in a data set. There's in Europe here privacy laws such as GDPR. In California, you also have CCPA. And so we kind of needed to track patient data through this database or through this pipeline. Imagine, for example, one patient retracting his consent for us to use his data. So we actually just want to be able to identify the models which are being used here on the other side with that patient record. So here, one patient is saying on the left, please don't use my data, and we having to identify on the right side where all of that happens. If we briefly switch back to this mode here, we actually see there are a number of different systems involved. So our data might lie in a distributed file system like HDFS. It might come in streaming from Kafka. It might lie in ArangoDB. And then on the other side here, we have some model serving. And through that, it has gone through a Jupyter notebook. It has gone through TensorFlow. It has been stored in our model management directory. And so figuring out which models were impacted by this one patient withdrawing his consent for us to use his data was actually very challenging. And we sat there for over a day pulling the logs from all those different systems and kind of merging them. So that was really a scary experience. And also it didn't feel like a best use of our time. So, and while doing that, we also had a number of other challenges coming up. For example, just understanding the complete provenance of our model. So where's our model coming from? This can be the data set challenge we just tried to solve. That can be an audit challenge. Where, for example, in finance, I need to have an audit trail. How did I get to a decision that a bank declines your credit request? If you challenge that model, it's good if they actually have a trail on saying, like, our model was trained like this. Here's the model function, here's the data set, and actually be able to have an audit trail for that. Also having a complete version history. As mentioned earlier, it's an often occurring case that we get multiple versions. If we get new training data, we retrain. So we actually have version 1 of a model, version 2, and so on and so on. And also just keeping track of all those different versions, it was a big challenge for us. Similarly, if I'm a data scientist or I'm a data ops, I want to find all models in production. I want to find all models in my model store. I want to be able to compare the performance of different models, or also even just if I'm a data scientist, identify reusable steps. So we felt we had like this big pipeline, but it was like all individual parts and was really hard to make, to give answers which actually involved multiple parts of this pipeline. And so this is actually why we shifted our focus from just talking about data to talking about metadata. So we ended up engineering a common metadata store, actually tracking our entire metadata through this pipeline. What do we mean by metadata? So Kubeflow, which is another machine learning pipeline, has this definition that it's information about execution runs, models, data sets, and other artifacts. But typically, it's not the data itself, for example. So, for example, here, a data set might describe where does a data set lie, which version does it have, and typically I would also recommend to just store some hash so you can actually check the integrity of your data set. Then the transformations is how was that transformed, what Spark job was used, what other things were used, what features were generated from there, what Jupyter notebooks were used here. Then for our training, like how successful were we on train performance, how successful were we on test performance, where's our model stored, what version number does it have, and then which models are currently being served in production. And often if I'm doing some online tests, for example, predicting click-through rates on a website, I often also get like live serving statistics, like how good my model performs in production. And so that's also good to get this metadata linked to the rest here. And this is then why we actually looked at ArangoDB and why we as ArangoDB came up with ArangoML Pipeline. So ArangoML Pipeline, it's an extensible metadata layer for machine learning pipelines. And this is kind of the important part because this model or this pipeline, it might not be the same for everyone. And you might come up in your environment with your own way. So for us, it was really important to keep that flexible and extensible for different people and allow them to focus it to their needs. So that was September last year when we announced that. And maybe just on the rationale why we choose ArangoDB for that. We talked a little bit about the multi-model aspect, which ArangoDB is supporting early on. And so the key factor for us was that we needed to combine two different kinds of data models. So on the one hand, we wanted to store the individual outcomes. So for example, the training and test results, that was like perfectly stored in a JSON document. But on the other hand, we needed to kind of like link all those JSON documents together. So we needed to have kind of like a reference from this is the training outcome to those features were used, this model code was used, this transformation, and so on. And in the end, this data set was used. And this is where ArangoDB allowed us to actually combine that, where we can have our document structure here to store the individual results, and then actually have a graph structure coming up, linking all the different documents together. And then queries can be easily expressed as a graph traversal. So just finding out like which models are derived from a certain data set, it just becomes like a graph traversal and graph reachability query. And so it makes it super easy to find all the related artifacts here. And once we had something like that, it actually turned out it was useful for many different actors in that field. So we already met our data scientist, the hero, but in reality, that hero, he cannot be efficient if he doesn't have like helpers, like the data ops engineer or the administrator. And actually, it turned out for all of them, it was super useful to have this common metadata store. So the data scientist, he can find entities for a given model. Imagine you're onboarding a new data scientist and you tell him, please improve that model. It's super helpful for him if you can just easily find out, like, here's all my information related to that model. He can explore performance differences, or also search and just reuse different entities. The data ops guy, she could actually get audit trails, trace data lineage for privacy reasons, such as GDPR, have reproducible model builds, which is also a common challenge in machine learning infrastructure, that it's super hard to actually rebuild the same model over time, detect data shifts, or figure out when a model is not applicable anymore because the data distribution has changed over time. And also the general administrator or the owner of that entire cluster infrastructure, it was helpful for them as well, because they could do resource accounting, figure out who's burning the most GPU hours, and also permission tracking, who's actually allowed to do what here. As mentioned, we wanted to keep things flexible. So this is why schema is in quotation marks here, because you can actually identify your own entities here. We got some default entities set up for you, which are just easy to use from the UI. But in theory, you can just come up with your own new artifact type. And as we form that graph structure in between, you can also come up with your own graph connections in between. So ArangoML, it's a Python package, also has an HTTP API, and we are working on releasing the TensorFlow extended integration. So if you're using TensorFlow extended, it just works out of the box. And it's actually super easy to use from like your notebook or any Python code. Just import that and you're ready to go. It also comes with its own UI. So you can, for example, search for metadata, you can search for deployments, and you can also just see that entire graph structure again, where you see like where everything is connected to deployment. And here we are coming again to graphs as we get to see what's actually going on. And again, this is for us humans, this is a very easy way of visualizing that. As mentioned, like TFX, just real brief, that is the TensorFlow ecosystem. And here we are basically working on our integration to be like one of the easy databases down here. Question now is just, how do you get started? Easiest is you just use Docker, run that Docker image, and you're ready to go. But how do you do that in production? How do you keep your data safe? How do you make sure you can upgrade your cluster? You can do backups. So basically, how do you get like a full-fledged ArangoDB cluster behind? Because ArangoDB is kind of the backing cluster for ArangoML. And it turns out my internet is slow. I hope you guys can still hear me. And so this is why we actually came out with ArangoML Pipeline Cloud. Let me see whether I can switch back. This is why we came out with ArangoML Pipeline Cloud. So it's a fully managed cloud solution. It's actually based on our managed solution for our database for ArangoDB. Let me just briefly check the chat. There's a question about PyTorch. I would answer questions in the end if that's okay. So ArangoML Pipeline Cloud, it's a fully managed cloud solution. And it's built on our managed database solution called ArangoDB Oasis. So we just leverage that underneath and deploy a fully managed solution of ArangoML Pipeline for you on top. There are two kinds of SLAs. To make it easy to start, there's actually a temporary cloud instance with no setup. So you can just use that from your Python code. We will auto-generate the database for you. And we also, you don't have to do anything. And we'll hopefully see that when Chris is giving the demo later on. Then there is a production support where you basically get your own Oasis deployment, your own, where you have full access, full administration control about everything. And you can also define your own backup strategy. So kind of your data is safe, whereas the first is more thought as like a temporary trial solution. Seemingly the internet is getting slow, but we are at demo time, so it doesn't matter that my internet doesn't like me anymore and doesn't want to display the pictures here. So I would actually hand over to Chris, who's now going to showcase all of that with a live demo. Chris, are you ready to roll?
I am already. Thank you. Okay, so the first thing I will do is make sure that I can share my screen here. And there we go.
In the meantime, I will briefly answer the PyTorch question. We already have example notebooks for PyTorch up because I'm also a big PyTorch fan. So you can already try that out. We got example notebooks, but there isn't like this ecosystem around PyTorch yet where we would have the automatic like inclusion. So that's more targeted to TFX, not so much TensorFlow itself, but you can definitely use ArangoML Pipeline together with PyTorch. Chris, we see your screen.
Excellent. Okay, well, I'll take it away then. Yeah, and as Jörg mentioned earlier, I am the developer relations engineer at ArangoDB. My video, it doesn't seem like we were able to get it working, but you may recognize at least my picture from some of the video content that we have on our site, in YouTube, and with the Getting Started with ArangoDB Udemy course. My day-to-day at ArangoDB is basically using ArangoDB as much as I can, with development. I'm also participating in things like QA testing for upcoming releases, and really just in general, trying to partner with the community to figure out any difficulties in getting started with ArangoDB. For this project, I was fortunate enough to work with Jörg's team on the Arango ML project, and specifically in getting it to work with Oasis and bringing it to the cloud. So that's kind of what I will focus on today. Is we're just going to walk through an example of using Arango ML Pipeline with some of your like pre-existing workflows. So the first thing we wanted to show was how quickly you can get started and start actually seeing it in action. So for our example notebooks, you can get started with a temporary cloud instance. And as Jörg mentioned, it doesn't require any sign up. And for this example, we're going to use pretty much the simplest use case we could, which is the TensorFlow 2 Quick Start Guide for beginners. And again, with the goal being that we try to avoid changing anything about this Quick Start Guide and instead just dropping in Arango ML. So we'll kind of get started with the first thing that you always need to do is install the required packages. And some of the callouts here are the Python Arango, that's the Python driver for ArangoDB, and the Arango pipe package itself, as well as some sort of utility packages that we use. So I'm going to go ahead and get that started. And while we're waiting on that, the next block of code is just right from the TensorFlow guide, and that's just installing TensorFlow to use in the notebook here. And looks like we're good to go there. And now this next section is actually the setting up the connection to the Arango ML Pipeline Cloud database. We start with importing Arango pipe, admin, and the configuration packages. These lines that follow are purely just for setting up the configuration and the configuration file. And this managed service con param, or the MSC here, is involved in creating a configuration file, which we'll actually take a look at in a moment. We're going to export it and take a look at what's actually in there. But for now, we're just looking to contact the Arango ML cloud instance that we have that actually creates that temporary database for us. So I'll go ahead and set that.
Basically, the idea for the connection file or the connection parameters is that you can actually reuse that. As mentioned, we're going to temporarily create that instance for you, but for you to be able to reuse it, Chris is also going to show how to share that file later on.
Right, exactly, and so the idea is what we're about to do is we've basically created some connection configurations, and then we use those during the connection, but then we can export them so that it's just a file. Like for instance, you know, even if this wasn't specifically for connecting to the cloud and you wanted to have an on-prem setup of this, you could export this file and give it to the user, and now they have their connection file they can use to connect, and it makes it fairly simple that way. And this will just take a moment, as right now we're actually contacting our Oasis deployment and is creating a database, a username, and a password for us that we're going to use throughout this. So this can sometimes just take a moment here. There we go. Okay, so now we've got that. I'll show you what we have in there. And this section here is, I'm actually exporting it to Google Drive. And this is just sort of a convenient way. Of course, you don't have to do this, whatever ends up working best for you there. And let me go ahead and I will pull that up for us now. Just takes a second to appear my drive so I can download it. Okay. Okay, and so this is an example of the configuration file that we'll use. And so you're going to get information like the URL that you should be using when connecting, but then also, importantly, the database that's been created, the username, and password. And this is the basic setup, and this is the file that will eventually save and can be reused, and we'll actually reuse it towards the end of the notebook here. So I'm going to go ahead and switch back. And okay, now that we have our configuration and connection set up, we can continue on with the TensorFlow portion of this guide. This is the setting up the MNIST dataset, which contains handwritten images of handwritten digits. So And that is all that takes for that section. And okay, so this next part is actually for preparing the data. We can start registering entities with Arango Pipe. This is very specific to Arango Pipe. You can actually register entities such as data sets, feature sets, and model metadata. This is really where Arango Pipe starts to shine. We're actually registering descriptive identifiers for the experiment that we're running in this notebook. So for this example, I've set up the project name, data set information, feature set information, and model information. And I've also added some print statements here just so we can kind of get a better idea on what's happening. I'm going to go ahead and run that. And so it sets it, it calls the register functions. And this is basically what we get out of that. It creates documents with these identifiers here. In ArangoDB, a document has certain system attributes that are always created with it, and that's the underscore ID, underscore key, and this underscore revision tag here. Whenever you want to look up a document, you can always look it up using either the ID or the key. This is, the revision is typically only used for like internal system operations. So, and we'll actually reference this a bit later, like this model. We'll try and do a lookup on that in a moment when we're exploring the UI as well. Okay, so now we've got a project set up. We can kind of continue on, and we'll add to this project as we go. The next step in the TensorFlow guide is creating our Keras model. Let's go ahead and do that. This also sets the optimizer and loss here. And this next portion is a little bit different from the original TensorFlow. The reason for that is that we are actually concerned with capturing some of the model parameters and model performance data. So we want to set it up so we can start storing and getting some useful data here. And to do that, we create a timestamp because that's what we associate with it, and as well as a run ID. And then we store the loss, accuracy, and performance data in this model underscore performance here. So let's go ahead and run this. And while we're waiting on that, actually, I'll give just some quick insight onto what's happening next. These next few blocks are purely just for sort of converting some of this data to JSON. At the very end, we check the accuracy of what we stored by recreating this model. And in order to do that, we need to have it in JSON because there are some TensorFlow functions that can make use of that. And again, that's just basically to show that what we're storing is accurate and checking it. Okay, we'll go ahead and do that. So we're storing the weights and the model in JSON here itself. Okay, and so this is another section here of pretty much purely Arango specific stuff. We are actually now taking all that data that we just created in the above steps, and we're going to store it as a run. So we're logging all of this data that we've created. And a couple of the callouts that I wanted to do here are these underscore keys. These are references to those documents that we created earlier, and they're being used to create documents stored in what we call an edge collection. This step is actually what allows us to view our data as a graph rather than just having multiple collections of these independent documents. And as Jörg mentioned, this is actually a benefit of using ArangoDB and how Arango ML Pipeline benefits from using a multi-model database. The full breakdown of how ArangoDB handles graphs is beyond the scope of this talk, but if you would like to learn more, definitely visit our Learning Center on our website, or even feel free to reach out to me directly. Okay, let's go ahead and run that. And once that's finished, I also wanted to show, so I'm going to print this run info and the model. And the reason for that is that should reference the same key here, ending in 6.7, that we set up here. So just kind of showing the connection on what's happening. We've got data, it's coming down, and now we're registering that to create all of these connections. And so if once we start querying data, they're all properly connected. Okay, so that's really the bulk of it. That's the main workflow. We've gone through, created a model, and now stored it. Next, we would consider this a situation where maybe we want to come back and look up this data, or just actually start using some of this metadata that we've stored. This is where we start needing to reuse that connection and make use of that configuration file. So in this situation, again, I'm just pulling it from Google Drive. So this is going to be the same file that I just created, but instead this time I'm setting our connection parameters. As well, in this first block here, if you're not doing it in this way and you're just using it throughout your app, you can just continue using it. You don't have to reform or establish a new connection every time. You can continue using that configuration that you already have. Okay, and in this next block, the main thing I wanted to point out is that we do have our reuse connection set to true, and we're passing through our configuration file that we're creating. Okay, and that's it. So a lot quicker that time as well, because we didn't need to create a whole new database or anything like that. We just immediately get reconnected. And now that we've done that, what we should be able to do is look up our model, which was named neural network up here. We should get the data associated with this model. And again, we should get that key in this document back as well. And so we do our AP lookup, and now we have the same key, our neural network, and the type. And this is just all the data that's been, a part of the data that's been stored as we've been going through this. And now we are actually going to recreate our model and then compare it with the what we have stored versus what we have immediately available here. And again, this is just more of a check to make sure that what we're actually storing is true. This is not something that you'd probably need to do in like day-to-day and using anything. This is just more for showcasing what we have here. And so if the model that we stored is matching the model that we have existing right now, then this should return true. And it does. All right. Okay, so that was really the main thing that I wanted to show there, but now I'd like to explore a little bit. We have a couple of ways to continue exploring the stored data. We can access it via the ArangoDB web UI, or we do have, as Jörg showed off, an Arango ML user interface as well. The ArangoDB web UI, however, can be accessed by going to the URL that we saw earlier and by using that username and password that was stored in the config file. So let's go ahead, and I'd like to take a look at that as well. And so right now, I need to pull up my config file again to make sure I'm looking at the right name. So we're working with the one ending in 4J, which we'll see a bunch of them here. Refresh, actually. There we go. Okay. And I'm actually signed in as root, but you can also sign in with the supply username and password, which you would have to in this situation.
Because only root has access to all, right? And
right, exactly.
Each
yes.
user
So
only
maybe
gets access to his own database.
Yes, I just happened to be signed in to make this part go a bit quicker for us. But yeah, in general, the only database that the user is going to have access to is the one that was created during that initial process. But once they get signed in, this is the exact same dashboard they'll see, and we can start doing things here. Like if we look in our collections, you can see it created quite a bit for us while we were going through that process. And these are the collections that are getting filled up as you do your experiments and as you're putting in metadata. This is how it's being stored. And there's a couple ways to see what's happening inside of these. One is a quick option I'd like to do, which is we can do a query to try and find that model that we've sort of been tracking throughout the process. And that model is stored in the models collection. And I'm going to need to make sure I'm what it even is. Here we go. So I'm just going to look up the key, which is here. So actually, I'll copy all of this. There we go. Okay, so that's what we were hoping to see, is that it finds our document that was created and with our model metadata information. And of course, you can start doing more complex queries from here. But the main point was just seeing what's happening. We're actually creating data within this ArangoDB database. And another neat thing to do is throughout this process, we're also creating a graph. Like I mentioned, part of the benefits of using this multi-model database is we're not just working with a document store, we're also having access to all the graph database features. And so what I'd like to do, we can pull all of that actually, so it's not too big. And then we can set the label to be the name. And so we can get an idea on how some of this data is actually connected. So we have our model, we have our data set, and what's actually within the data set. And as you add data, we start seeing more and more of these connections. And so this is our neural network. So this is our model again. We look at it, here it is again. And just showing the relation that it has throughout the project. And as you add to it, this graph gets more complex and a bit more descriptive. Yeah, I think aside from that, the only other thing I wanted to point out was this is a fairly simple use case, but we do have a lot of other feature use cases, such as detecting the biases in this one, and dealing with the covariant shifts in both our repo, as well as if you take a look inside the actual Docker images and spin it up on your local instances as well. We have even more notebooks available in there that go into the different details. But if you're looking for a good place to get started, I would definitely suggest taking a look inside of our examples folder, as we have some really good use cases that kind of go one step further from what we looked at today. All right, and I think that was everything. If anyone has any questions, happy to, I think, possibly answer now, but I'll hand it back to Jörg.
Thank you so much. This was a really cool demo. Can you also let me share again my screen? That means thank you so much. So let me hit share again, and I think it's just one slide left, which is basically saying thanks for listening to us. And now also Zoom is in the way, but here we go. Let's just go there. All right. Thank you so much for listening. Here are basically all the further links for going to ArangoML Pipeline itself, which, by the way, all of this is open source. So ArangoDB itself is open source. ArangoML is open source. We have a blog post around ArangoML Pipeline Cloud. Here's the Getting Started notebook, which Chris actually just showcased. So just jump in and actually try that yourself. And then furthermore, you can actually test drive ArangoDB and ArangoML, obviously, then as well, using Oasis with like a 14-day free trial on the cloud. So as mentioned, Oasis is a managed service for ArangoDB. So this is basically a very easy way to get started with all of that. Having that said, thank you so much for listening.